Hi everyone, so we're going to look at lesson 1.7 today. So this is going to be our final lesson of the unit before the test. So today this is going to encompass pretty much everything. So we're going to connect the number of solutions to a linear system based off of its equations and graphs. So this is going to be really interesting. It's going to summarize a lot of our points that we talked about. So the first point to remember is when lines are parallel, their slopes are always going to be the same. So that means that if we have this example here, we have y equals 3x minus 5 and y equals 3x plus 7. The slopes are going to be the same, but the y-intercepts are different than one another. Okay, because of this, they are parallel lines. The coefficients in this equation are constant multiples of one another, but the constants are not. Okay, so remember this is very important. So you can see here in the graph, they're parallel to one another. We have our coefficients are not the same, but they are multiples of one another. Okay, but the constants are not constant, okay? So it's not going to be 3 the entire time. They're multiples. So for the example here, we have 3x plus 2y equals 8, and then 6x plus 4y equals 40. Okay, so looking at this, we're going to separate them off to the side a little bit. So we have 3x plus 2y equals 8, okay, for this. And then we have our other example on the side there, which is our other one. We're going to separate that here, and we're going to isolate it so it's the same format as what we want. So actually we're going to change this up a little bit. So we have y, we're going to put it as 2y equals negative 3x plus 8, because we want it in the format as y equals mx plus b, and then we're going to do the same on the other side. Okay, so now we're going to isolate our y's. So we're going to divide by 2 and by 4. So y equals, so negative 3 over 2 will stay the same, plus 4. And then on the other side, y equals negative 3 over 2x plus 10. So this goes to show that even though we have two separate equations that are different, just like on the graph, we have very similar points here. So we have our negative 3 over 2x and negative 3 over 2x on both sides. Okay? So that is very important to remember here. So parallel lines here in this case, they never intersect, and therefore they have 0 solutions. Okay, so please make sure you write that down. I will pause for 2 seconds to make sure that you have written this all down. All right. Now, so when the coefficients and constants in the equations are constant multiples of one another, they are technically the exact same line. Okay, so that means that they overlap each other, and therefore they intersect at every point. So therefore, they have infinity or many solutions. Okay, whatever way you want to say it. So in this case here, you can see that if we compare these two examples to one another, we find a common denominator of both of them. Okay, so we just have to multiply it by 2. For this one, this has to be multiplied by 2 as well. We will get an equation of y equals 3x minus 5, okay, if we were to just divide or multiply. Okay, they're just the exact same. So they have the exact same slope and the exact same y-intercept. Then our last point here, so when the coefficient and constants in the equation are not constant to one another, they're not constant multiples of one another, they will eventually intersect. Okay, so this means they will have only one solution. So for this point, they will have different slopes and they can have the same or different y-intercepts, okay? So it really depends on the equation. So for example, we have y equals 4x plus 7. We can also say y equals 3x plus 7. So in this case, too, we will have only one solution, and that will be 0 and 7 because the 7s are the exact same. Okay, so we're only going to have one solution. That's where they will intersect. So a little bit of a summary here. If we have no solutions, the same slope, and we have a different y-intercept. If we have one solution, we're going to have different slopes and same or different y-intercept. And if we have infinity or many different solutions, we're going to have the same slope and same y-intercept. Okay, so remember, little hint here, always put it into y equals mx plus b in order to determine and compare their slopes and y-intercepts. So I want you to look at the first examples here, A, B, and C, and I'm going to go over this one example with you together. So we're going to look at this equation here, and we're going to write another equation that will create a linear system. So remember, our m, oops, I didn't change it over. Sorry, our m is always going to be -2, and our b is always going to be +4. So if we have no solutions, that means we have the same slope and different y-intercept. So therefore, our y is going to be the exact same slope, which is -2x, but different y-intercept. So we can say a number like 7. Okay. The next, we have one solution, which is a different slope. And then we can have the same or different y-intercept. Okay, so having a different slope, we can say y equals 3x. Okay, and then we can have the same slope, our same y-intercept, so we can have our b, or we can say y equals 5x plus 7, just putting random numbers out because we're having different slope, same or different y-intercept. Now we can have many different solutions, so same slope, same y-intercept. Therefore, we will say y equals -2x plus 4. This is a multiple, so we have to multiply this by, for example, 2. So then we'll get 2y equals -4x, plus 8. Okay, so this is many different solutions. Always make sure that we're having multiples of our many different solutions. Okay, so please complete the rest on your own. The next examples goes over one solution, no solutions, infinity solutions. There is a YouTube video on this later on that is attached here, so you can complete that. Let me know if you have any questions, and I'll talk